So good morning, good afternoon, everyone, depending on your geographical location. And I'm very happy to welcome you to this mini series. Yes, our idea is to be able to provide you some learning and nice materials to better understand and play with the Open RAN, try to understand what is the internals of the xApp, what is the architecture of the ORAN. And we have been working towards this since a while, and we are actually trying to leverage most of the open source tools to make this happen. So I start my talk by presenting what is Open RAN. So Open RAN is more of a philosophy than a technology. So it's about a collective action in building an open telecom networks that complies to 3GPP. So in essence, the fact that it is a collective action, it means that it cannot be done by only one partner. It is an cooperative operation, a community-based initiative through which we could all together work towards this opening the 3GPP network so that we could create more innovation and do not restrict the innovation with the only single vendor. So historically, we had a problem of the vendor locking, in a sense that the network was all controlled with one vendor. So we try to move from a static vertical market with few vendors to a more dynamic horizontal market with multitude of the vendors and apply a white box open interface solution. So what I'm trying to cover here is that first thing is that it's a collective action, so we need cooperate all together to make it happen. And second of all is we are going towards more of a horizontal market in a multi-vendor environment. So if we look at the left side of the this slide, you see a traditional RAN whereby we have a single vendor, let's say vendor A, that provides CU, PU, and RU, and there is an interface between frontal interface. Please, can you? There are some noises here. We need to. Can you close your micro, the one who is speaking? Thank you. Thank you very much. Yeah, so we are moving from a traditional RAN where the interfaces are vendor specific. Some of them obviously are 3GPP, but some of them are non-3GPP, it's vendor specific and non-interoperable with the other vendors, towards an open RAN where the interfaces are open. So here, for instance, we see the vendor A interacts with the vendor B over the F1 interface and interface with the RU vendor C in the open frontal. So this is more to mix and matching different vendors, different network function together, and all of it ideally in a form of a white box approach. And all of the components are exposing an interface towards the higher level intelligence to make some decisions. So if we look at the ORAN architecture and the interfaces, here is what we see. So we are seeing from the bottom, we are seeing a cloud infrastructure, we are seeing the remote radio units, RUs, we are seeing the DUs, we are seeing the CU, and above all, we are seeing a near real-time intelligent controller, the RIC, together with the xApps. And we are also seeing the service management and orchestration framework together with a non-real-time intelligent controller, and there are app residing. So one natural question would be, why do we have this separation of the near RT RIC versus non-RT RIC in the ORAN architecture, and why we have policies there and the xApps there. Essentially, the answer to this question would be that, first of all, we need to notice that anything that non-RT, non-real-time rig could do, the near-RT rig also could do, because the time scale is much lower. So the separation here, to our understanding, is to separate the vendors from the operator. So the vendors are providing the near-RT rig with the xApp that is able to control the network element, whereas the non-RT rig, which is on the SMO part, service management, is mainly owned by the operator and enforcing some policies that is understood by the near-RT rig and consequently by the vendors. So ORAN specifies bunch of interface that you see on the right. So from the top, so we have O1 interface, which is from SMO to all. Essentially, it is a configuration interface to configure all of the network element, and it is foreseen that this O1 will be extended also to RU, which is today not the case. Then we have an O2 interface, which is the SMO towards the cloud infrastructure. The A1 is between the near non-RT rig and near RT rig interface. The E1 is a 3GPP interface, which is between the CUUP and CUCP. E2, again, is an ORAN interface between the network elements. So you see DU, CUCP, CUUP, they have an E2 interface towards the near RT rig. Probably this E2 might be extended at some point also to the RU, which is not the case today. Then we have an F1C, F1U, which is a 3GPP interface that is connecting the CU to DU on a control plane and on the user plane. And then we have an open fronthaul, which is the split option 7.2, which is from the DU to the RU. And this also allows to have a multi-vendor interoperability between different RU vendors versus different DU vendors. So now that we saw the architecture of the ORAN, what developers and in a more general case, the community of R&D and also the vendors, operators, integrators, they need a realistic end-to-end 4G, 5G ORAN platform and the xApps that are coming in order to be able to learn, to test, to integrate, to develop the xApps. And it's another trend here is also be able to leverage some open source component here so that the ecosystem becomes more open, so the community could actually also get access to part of the open source environment. So towards that, we have been working to actually create an integrated end-to-end environment. We call that Open RAN Studio, which if we see it from the bottom to top, it incorporates the cloud infrastructure, essentially a set of network of the PCs and the servers that are not necessarily geographically co-located. So they could be actually distributed in different geographical area. Obviously, we have a Linux environment and on the top, the Kubernetes environment. And then we have the workload, which is the 4G, 5G workload. So we have a RAN environment, we have a core environment, the RApp and the xApps, the RIC environment, the RU channel, and the UE, all in the fully emulated environment, and some utility to facilitate the understanding, testing, and measuring the performance. And on the top, there is a SMO that is sitting, which is essentially, we are leveraging the Kubernetes operator framework, which is an intent-based operator to realize this service management and operation in an end-to-end manner. So what we have here is the world's first production-grade cloud-native platform to seamlessly help you to design, a blueprint to operate your network. When I say operate, I mean from day 0 to day 1, day 2, and day n. Experiment the whole network in an end-to-end manner in an emulated environment that complies with the 3GPP and ORAN and at a scale. And this scalability comes obviously from the Kubernetes. So today's focus, if we want to map already from the ORAN to this environment, we see that the O cloud is these 2 bottom layers, which has the infrastructure plus Linux and Kubernetes. The RU is here, which is an emulated RU. So we are transporting IQ samples, but we are not actually transmitting over the air. We have a DU and CU. We have a near RT rig, which is called Flex rig. The actual network entities are based on OpenAirInterface that you see here. Both the core network, the RAN element, and the UE part, which provides the end-to-end emulated environment. And we have an interactive KPM xApp for today, together with the SMO and the CLI. So these stars are representing what we are gonna show to you today. And the focus of the today would be on deploying first a 5G standalone and then an Open RAN deployment. So what we could do with Open RAN Studio is the following. So Open RAN Studio has many capabilities which allows you to develop and build an xApp. So you can either develop based on existing xApp or use the template to create your new one. You can design a blueprint, and all of these steps to a large extent you are going to see in a live demo. So you can design your blueprint. What network do you want? You have different models, different topologies that you can describe. Then you can deploy and then customize the configuration file. So you have all the operations like installing the network, removing the network, upgrading the network, reconfiguring the network, and so forth. Once the network is deployed, you can test and measure the performance of those networks from the network performance, from the agility perspective, the network readiness, and how much resources have been used here in all dimensions. And finally, analyze and evaluate the user plane, control plane, and the performance, which gives you the full spectrum of what you could do with such environment, such an integrated environment. So now I hand it to Ilyas again.
Okay, thank you very much, Professor Navid. Now we're going to move to the next presentation. It's going to be about live deployment of a cloud-native 5G standalone blueprint. And again, Professor Navid Nikayan will present this one.
Okay, thank you. So to proceed, I want to show you first the steps that we have, and then we go actual to the demonstration, to the live demo. So we have a bunch of operations that are possible today with Open RAN Studio. So you have an operation of extract infrastructure, which actually shows you what is the provisioned resources, what infrastructure we have. It gives you a full picture of what we have in the infrastructure. Then the blueprint, so how the end-to-end network is described, access network, edge network, core network, and slices. Then you can install the network, like deploy the network blueprint that you just described. And you see on the right that this shows the day operation. So checking the infrastructure and designing the blueprint is a day 0 operation. When you go to the installing the operation and observing the status of the network and the readiness, you move to the day 1 operation. Then we have a test, extract, remove, and CLI in CLI commands, which are more like a day 2 operation. So with the test, when you deploy your network, you can on the fly do the test and measurement of the performance of the network. Extract will help you to extract some important information from the network, such as the logs, configs, and also the relationship between the network elements that you just described in your blueprint. You can also delete the deployed network by using the command remove. You have a CIC in order to embed workload commands. So you can actually and then upgrade, which means that you roll out any operations like a reconfigure and upgrade. So I show you without any hesitation the blueprint that we are considering today. So is this black rectangle that we see together with the core network. So on this rectangle, what we are seeing is that we are having a single vendor deployment in Open RAN Studio here, which incorporates soft UE, RU, and the channel, monolithic G-Node B connected with the UPF and the whole core network. So this would be the simple 5G standalone deployment blueprint that we are gonna deploy, and next we will move to another deployment. So with that, I will pass the screen to my colleague, which will deploy the demo for you in live. And please feel free to send us the questions at any point. We will try to answer you as fast as we can.
Hello, everyone. Good morning to Europe, Middle East, and good afternoon to East Asia. I am Ali Reza Mohammadi from Eurocom. I'm currently Navid's PhD student working on several projects related to BubbleRAN and in specific for this demo, Open RAN Studio. Without hesitation, I would go to the demo and show you the steps that Navid just mentioned. And then we are open to your questions after. So let's, I have already connected to the cluster of Eurocom, but the cluster that we have in here, we are SSH tunneling. So I'm showing the commands, I'm running the commands on my laptop, and then the commands are going to be executed on that target cluster at Eurocom. I hope that the screen size is okay for everyone. Then the first command that I want to show you is to show you the infrastructure that I just mentioned in a summary format. So if I run the command CLI extract infra, it gives me the whole cluster, which is a decently large cluster. We have 11 or 12 nodes, if I'm not mistaken, with variety of operating systems, of course, all of them Linux distributions, and different CPU architectures and the CPU vendors. This command, it shows you, as I said, the summary of the cluster, but since this Open RAN Studio is going to be the very minimal version for the simulation purposes, not every machine in the cluster would be actively participating in this demo. One or two of them should be enough for the purposes of this demo. So the first deployment that we are going to show you today is a rather simple 5G SA deployment. Let me open the deployment file. Let me increase the font size. So this is a description, a declarative description of the network that we are going to deploy. It introduces what type of PLMNs and APNs is going to use first at this section, as you see. And then it describes the access network section, which is in here. You are going to, for Open RAN Studio, we specifically use OpenAirInterface in RF simulator mode. So when you're defining the radio device to use, you specify it as RF simulator, even though the platform is capable of doing with any type of radio devices, USRPs, SDRs, remote radio heads. But for the purpose of this Open RAN Studio, to keep it simple, understandable, and very low priced, we're focusing only in the simulation mode that integrates very well also with the xApp environment and with the RIC environment that we have in general. the xApps that you develop on this system of OpenRAN Studio should be able to run as smoothly as on OpenRAN Studio on a production platform with non-simulated radio. You see also that the cell that I have defined is a single cell, a very normal single 40 megahertz cell. And then the core network again is OpenAirInterface. And if I go down, there is this section that I also define the network terminals. So one of the unique features of the OpenRAN Studio in specific and the whole platform in general is that it gives you the ability to also handle your different type of terminals. So you could have the RF simulator, you could have the UIs, you could have the external phones. And in specific, it helps you to not only incorporate that information in the core network, but also run the simulation in this case. So we are going to have two UIs, the UE1 definition is in here, and the UE2 definition is on this side. So now let's jump into the deployment. If I do CLI install network, I give the file, would install the network. So if you have, if you look at this column, the third column on, and here it would show the status of that specific workload, which if you have a wall clock in your hand, it should, if you measure it, it should take like around 4 to 5 seconds to make sure the whole network is ready end to end, including the UE that is connected. What reflects the status of the UE is whether the UE is able to connect to the internet, like to the external network. And how it does that is by some ping tests, regular ping tests. So as long as the UE's status is true, you could implicitly assume that the whole network is running very well. If it's just a few more seconds, the UE should be ready as well. So yeah, when the UEs are ready, now we are done with the day one operation. So I have done the deployment part. Then what I could do is move to the day two operations. For example, we could work with log extraction first. If I this extract logs, yes, and this command line features auto-completion features, so you could reliably press tab to see the custom name. So you see, this is I'm looking at the OpenAirInterface log. You see already the two UEs are connected, all the channels are established, and the parameters of that UE you could see in here. Then the next command would be that I do CLI. I could extract also the configuration that was used. So if I do configs, then I need to specify a target directory in my system where it would put the extracted configs. Then if I do here, you should be able to see all the configs that were used. And if I open the file, it is the final provided config to OpenAirInterface. So you could verify the values, whether they're the ones that are desired for your purpose or not in this setup. If not, then you could modify them by the declarative file that I just showed you. And another command is you could also extract a graph. This graph I will show you after because I need to switch the screen that I'm sharing. But it is essentially a summary graph of the whole network. Then if I could also perform the test actions as we mentioned. I could say test, in this case, say RTT is round trip time, and then UE1. Okay, if I click, then it starts pinging that UE1. So it is asking the UE1 to ping the gateway in this case. So it automatically detects which gateway it needs to ping, then sends the instruction to the UE, and the UE starts pinging the other end. You could also do traffic tests by saying throughput. For example, I want to do downlink throughput, UE1 downlink throughput, and then You could give any options that you could usually give to iPad. For example, like you say UDP --bitrate 40M and for say 10 seconds. Okay, let's see the output. So the output sometimes, because it's coming from SSH, takes some time, but the test is running. You would see the report in a few seconds. Voila. So this is the report. You would see this is the traffic that I sent, and this is the traffic that I received, and with the jitter and the values that you would see here. Then I think I'm done with the main commands. I could remove the network, and then I just show you the graph that it was generated. So I do CLI remove network. And when I do that, and if I go to the observe command again, you see that the resources are immediately deleted. So you could regularly do very short, very fast-paced and short-lived networking with this system too. So let me open up the graph. Need to stop sharing, share again. So this is the SVG file that it creates at the end from your network. So you see already, even with a small very smaller scale deployment with this Open RAN Studio, already there are a lot of different components involved that you could keep track of them. For example, you see, okay, there is a database here for the core network. There is the AMF, for example, for the core network. You come on the other side, you would see this is the GNodeB, and also the UEs, as I mentioned, are part of the system. So you could see that these are terminal UE1, UE2, and having the corresponding elements as well in here. I hope that I have left nothing more. So if it is finished, then we could, I leave the floor again back to Navid. Thanks for listening. I would be responding your questions in the chat.
Navid, you are mute.
So this is the blueprint that has been shown by Alireza, which consists of a soft UE connected to the GNodeB and connected to the core network with the end-to-end connectivity, so allowing to connect the applications to this network and essentially benefit from an end-to-end operation. And one thing I want to highlight is that the interface between GNodeB and the soft UE is actually going down to the physical layer. So we are transporting the IQ samples from the GNodeB to the UE. So it is, the level of realism is quite high. Now we want to move to the, so the 5-minute breaks, I think we are a little bit out of time. Elias, correct?
Yes.
So maybe we continue.
Maybe we could continue.
Yeah, we continue, but please continue your question. So the next blueprint that we want to show you is what actually the power of the Open RAN Studio is, to show you an ORAN deployment now that we saw the standalone. So what we are going to do is that we are going to split the GNodeB into DUCU. We are going to add the near RT rig, and we are going to also add an xApp. We keep the core network the same, but the blueprint of the RAN is going to change. So Alireza is going to show you that the blueprint is changed. And we are also, again, going back to the CLI to see what operations we can do. I also want to mention that here we have a artifact registry through which all of the images, when the operator is instructing, all of the images are fetched using this registry and then deploy it on the top of the infrastructure. So without any further delay, I pass it back to Alireza for demonstrating the deployment of the ORAN.
So
here.
Let's move on to the second example. Again, I show you the deployment file. I don't go through all the steps. I just do show you the deployment file. I show you the command. We install. We see how long it does it take to come up. Then I directly jump to the xApp section of it because the rest you have seen already with the other one. So let me open it with Beam. This time, the network that you would see is that in Access network now, we have two GNODBs. One is the one that is running with monolithic, and the other one is also running as disaggregated CUDU. And this is the indicator that which deployment mode you are going to use. So it's CUDU with E2 interface, and this is like monolithic GNODB with E2 interface. And then you have the core network similar as before, but now in the edge section, you have the near-arteric, which is going to be FlexRIC in our case, the monitoring xApp written in Python for interactive mode that we are going to demonstrate today, and a database that is going to represent the data layer is a MySQL database that is the new version of database support in FlexRIC. Before we had SQLite, but now we could use it with MySQL, and you could, instead of connecting the MySQL with Open RAN Studio, you could also share it with any other database backend that you have in your setup. And then we would show you how to interact with the xApp and how to interact with the data in the database for the ones who want to do training based on data or data collection in general. I have the previous two UEs that I had, UE1, UE2 again, and now I have also UE3 that is going to connect to the CUDU deployment. How it knows which one it should connect to, because it is a simulated UE, there's no stronger signal or weaker signal. So what it does is that we specify here the preferred access section, what access network do we prefer this simulated UE to connect to. So let's deploy this. If I go back now, you see more elements on the left side, but the time of deployment should roughly remain the same. It means that the scaling for the deployment in Open RAN Studio in a specific or the platform in general is flat. So it doesn't change based on how many different, I mean, it changes roughly, but it doesn't change linearly or exponentially based on how many newer elements you have. So it could handle even larger scale networks, which is some parts of it is coming from its parent Kubernetes. So it is featuring all of those from Kubernetes and keeping them alive in here. So you see already the status of the networks are changing. So my CU is already connected. The DU is still waiting because of doing all the other setups, including the F1 interface. But the monolithic GNODB is connected already. You see the status is true. So it means that the two UEs is two UEs that were connected to the monolithic one, they connected first. And then the third one, which is going to connect to the DU because it was waiting for the DU to be ready. And after a few seconds, the last one should be ready. And then I go further into it. So you see also the Python xApp here that is I'm going to connect to. The command of interest in here is that we could communicate with any other interface, any other command line interface that is provided by the network functions or elements in general that we have deployed in this network. The command that we named it is CIC, stands for CLI inside CLI, CLI in CLI, which in this case, I want to use the Python CLI that I had for that xApp inside that network function and attach it to my terminal that I'm running in here so I could directly issue and interact with the xApp. So if I do CLI CIC Python xApp, and then if I, for this case, I need to tell it to also follow the commands. So don't do it in one shot. And then I need to say the generic command run, and then I say, give me the Python xApp. If I run this command, then it is giving me that back the Python terminal inside that xApp, this is Python 3. Then if I do import xApp to import all the utility modules that we have created for the xApp, then I have them all in my hand. The first action that I need to do is that I do run xApp init. What this command does is that first it detects which type of service models are available to use. You see already FlexRig supports a bunch of them, but what we are going to use specifically for this demo is we are interested in ORAN E2SM KPM service model. And here is when it is connecting to that set database. So you see the command is pointed at MySQL and is creating all the required tables. This KPM table is the one that we are going to interact with. And then finally, you would see also it is communicating with E42. E42 is the interface between the xApp and the FlexRig to send and receive all the communications, including indication messages, control messages, the data that is coming and going from the xApp to the RAN. So after doing the E42 setup with FlexRig, it gets an ID, which in this case, like the xApp ID is 7, and then it gets the list of registered nodes. So this list is dynamically generated. Like if I started the xApp sooner or later, we would receive the update notifications of how many GNodeBs are coming and going. But at this moment, because it was already connected, all of them, I received the 3 E2 nodes. So I had 2 GNodeBs, but 3 E2 nodes because the other one was splitted to CUDU, which in ORAN definition are 2 separate E2 nodes. Now you see they belong to the same MBID, 2NE in this case, and both of them are for MCC MNC1 for test PLMN. And what we are going to do later on is to subscribe to these E2 nodes for the KPM service model with the desired parameter that we have. We would fill in the database, and we will show you also some graphs. But here at the moment, I want to pass it to, again, to Navid's screen, but with my colleague, Cheechan, who is the main developer of xApp and FlexRig in our part, to show you a few points about the xApp. And then she would come back to the terminal that I have in here to show you some interaction with the xApp. Thanks for listening. I would be responding to your questions in the chat.